Purpose of this video is for you to be able to use the four-step format to calculate molarity. Molarity is when we've got a solvent, a solute, in this case sugar, and we've got a solvent, pretend it's water, and we put them together to make a solution. So we combine them together to make a solution. And in this case, let's pretend we've got 23 grams of solute and 150 milliliters of solvent, and we want to know what's the resulting molarity of the solution. Now, when using the four-step format, there are 4 steps. The first step is what do we know, our info step. On the last slide, we knew 2 things. First being that we had 23 grams of our solute, 150 milliliters of our solvent, and we wanted to know our molarity, and that's what we were trying to figure out. So that's the first step. Now, there's more to it, because if you look at the next thing we need, which being our formula, you'll notice that the solute needs to be in moles and the solvent needs to be in liters, and our solute is in grams and our solvent is in milliliters. So this unit and that unit and that unit and that unit don't jive. So we need to do a couple conversions. So we're going to start with the top one, going into moles. Now, in order to do that, you got to calculate sugar's molar mass. So you look at this, find out the elements, carbon, hydrogen, and oxygen. You find out their their average atomic mass from the periodic table. You multiply that by the subscripts, and you get these products, and then you add them up, and you get 180, and that's our conversion factor. There's 180 grams per 1 mole of sugar. Now the next conversion is, or the first conversion, not the next conversion, the next piece of math that we need to do is to convert the grams of sugar into moles of sugar. So the first thing we're going to do is we're going to draw it on a bracket, all right? And we've got this conversion factor here, and now we can arrange it being always putting them on the diagonal. The 80 grams goes there, and the moles goes up top. So it's going to look like that when it's all done. All right? Now, the next thing to do is to cancel my units. So I cancel those and that, or that and that, and then I multiply across. So 23 times 1 mole gives you 23, and you just carry the 180 over, get 180. Then I'm going to do the division. 23 divided by 180 is going to be 0.13 moles sugar. Now the last conversion that I need to do is I got to convert this milliliters into liters. Now remember that there's 1,000 milliliters in a liter, so when I use dimensional analysis, first thing I'm going to do is put my thing on the top left-hand corner of the bracket. Then I'm going to use my conversion factor of this, and the 1,000 is going to go here, and the 1 liter is going to go there, and this is what it's going to look like. All right? And then I would cancel my units. The milliliters are going to cancel away. I'm going to be left with just liters up top, and then the next thing is to multiply across. So I get 150 L over 1,000, and then I divide. So I've got 0.15 liters. Now the next step in the 4-step format is to substitute. That means to plug the numbers into the formula, now that I've got them in their correct units. So X is equal to 0.13 moles sugar or C6H12O6 over 0.15 liters. That would complete the substitution step. The last thing to do is to solve it, and in this case I simply do a division, or I simply divide. And I'm going to get 0.87 molar sugar. So, note Molarity's unit is M with solvent, ute. Here's my capital M, and here's my solute. That's how you write it. And finally, what this means is that molarity of this sugar solution is 0.87 m or molar sugar, which means that there are 0.8 moles of sugar for every 1 liter of solvent. And that's how you would calculate molarity using the 4-step format.